People always ask me, Albert, how did you come up with the theory of relativity? And I smile, because the truth is, I didn't find it in a laboratory. I found it in my imagination. The story you are about to hear is not just about equations or light. It's about how one idea, born in the mind of a young man with no job, changed the way humanity understands time, space, and the universe itself. So sit with me for a while. Let me take you back to where it all began. When I was a boy, my father gave me a compass. No matter how I turned it, the needle always pointed north. I remember staring at it for hours, asking myself, what invisible force is moving this? That was the first time I realized the universe hides secrets that cannot be seen, only felt. In school, I was not the best student. Teachers thought I was slow because I questioned everything. But curiosity, that was my true gift. I never stopped asking why. And that curiosity became the seed of relativity. When I was 16, I imagined chasing a beam of light. What would I see if I could travel beside it? That simple question changed everything, because it made me realize that light is special. It moves at the same speed, no matter who watches it. Whether you are standing still or flying through space, light always travels at exactly the same pace. That was the beginning of the theory of relativity. Before me, science followed Sir Isaac Newton's laws. Newton said time and space were absolute, the same for everyone, everywhere. He wasn't wrong, but he wasn't completely right either. Newton's world was like a giant clock, the same tick, the same rhythm for all. But I discovered something shocking. That clock does not tick the same for everyone. Time can stretch, it can slow down, it can bend. And space, the thing we thought was empty, is actually woven together with time, forming a single fabric, space-time. I had no lab, no assistants, no money, only a notebook and my imagination. So, I began conducting thought experiments, experiments that happen in the mind. I imagined trains moving near the speed of light, and people on those trains looking out their windows. To one person, a flash of lightning might strike both ends of the train at once. But to someone standing on the ground, one flash would come before the other. Who is right? Both, because time and simultaneity are not absolute. They depend on the observer. That's relativity. The truth depends on where you are and how you move. The faster you move, the slower time becomes. If you could travel close to the speed of light, you would age more slowly than those who stay behind.
A minute for you might be an hour, a day, or even a year for someone else. And this isn't fantasy. It's been proven again and again with atomic clocks and satellites. So, yes, time travel, in a sense, is real. Not through magic, but through motion itself. Imagine the universe as a fabric, a soft, flexible sheet. When a massive object like a planet or a star rests on it, it bends the sheet. And when something smaller moves near it, it follows the curve of that bend. That curve is what you call gravity. So gravity is not a mysterious force pulling things down. It's simply space-time bending around mass and energy. When you drop an apple, it's not being pulled. It's falling along the curve of space-time created by Earth. Years later, I found the simplest expression of this truth. E equals mc squared. Energy equals mass times the speed of light squared. It means that mass and energy are two sides of the same coin. Matter can become energy, and energy can become matter. The sunlight that warms your face was once the energy trapped inside atoms at the heart of the sun. That single equation explains the power of stars and even the destructive energy of atomic bombs. But my work was not just about equations. It was about understanding the harmony of the universe. I once said, imagination is more important than knowledge. Because knowledge is limited. Imagination embraces the entire world. Without imagination, I could never have discovered relativity. It allowed me to travel through space and time inside my own mind. And you have the same power, my friend. Every human mind holds the potential to reshape reality. When I first shared my ideas, many scientists laughed. How can time slow down, they said. How can space bend? But slowly, the evidence spoke louder than their doubts. Solar eclipses proved that light bends around the sun, exactly as my theory predicted. And then world began to believe. Relativity is not just a scientific law. It's a way of seeing life. There is no single truth, no fixed reality. Everything depends on your point of view. That's why compassion matters. If you wish to understand others, you must see the world from their perspective. Even time itself teaches us empathy. The universe moves differently for each of us, and that's what makes it beautiful. Today, my theory powers satellites, GPS, and even the understanding of black holes. It has reshaped physics, astronomy, and philosophy. But the greatest lesson it offers is this. The universe is not a cold machine. It's a living symphony of energy, time, and space dancing together in harmony. And we, tiny humans, are part of that dance. So when you look at the stars tonight, remember this. You are looking into the past. The light reaching your eyes has traveled for millions of years. You are not separate from the universe. You are made of it. Time, space, energy, they all live within you. The theory of relativity was never about proving I was smart. It was about showing that the world is far stranger and far more wonderful than we can ever imagine. And that, my friend, is the true beauty of the universe.